So the instruction for the challenge. So each question, right, will be flashed on the screen for 1 minute. So total there will be 10 questions and total time will take 10 minutes. So if you have finished, you can skip forward, and if you take a longer time, you can actually pause the screen. Okay. Next, after that, you can skip to what? 10 minutes and 30 seconds to check the answer. And then if you need a solution, you can skip to 11 minutes. Okay. So first question. Okay, next one. Question 2. Okay, question 3. Okay, moving on to question 4. Okay, moving on to question 5. Okay, moving on to question 6. Okay, moving on to question 7. Okay, moving on to question 8. All right, moving on to question 9. All right, moving on, the last question. Alright, that's the end. Next, you can check your answer. For question 1 to 5, the answer is C, D, 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 A. And then from question 6 to 10 will be A, B, A, C. Okay, so you can check your answer here. So don't forget to post your result on the comment section. Okay. Okay, next we will go through the solution for each of the question. For question 1, okay, so the diameter of a pencil is measured using a micrometer screw gauge. So you have diagram A and diagram B. Diagram A is for your zero errors reading, and then diagram B is for the reading of the diameter itself. So if you see from the diagram A, your zero error will be what? 0.01 mm. Because if you see here, this is your horizontal line. So here is a 0 mark. Here will be 0.01 mm, 0.02 mm, 0.03 mm, and so on and so forth. This is 0.05 mm. Okay, so this is 0.01 mm. Next, for your measured reading, you look at diagram B. So this is 0, this is 1, this is 2. So this in between is 0.5. So you can take it as 0, 0.5, 1, 1.5, 2, 2.5. Okay, so it's 2.50 plus from the smaller scale. Here is 0.35, 0.36, 0.37, and 0.38. Okay, so when you add them up, you get 2.8 mm. And then finally, for your corrected reading, right, you have to always use what? Measured reading minus away your zero error. Okay, so it will be 2.88 minus 0.01, you get 2.87. So answer will be C. Okay, question 2. So this is a simple pendulum. It swings from A to B. The period is shown below. So this shows you different length. If it's 0.5 meter, you get 1.429 for period. And if the length is 0.6, is this timing 1.565, so on and so forth. So now they say, if the length of the pendulum is 0.68 meter, okay, what is the appropriate time for 20 oscillation? Okay, so from your table, 0.6 meter is 1.565 second, 0.7 meter is 1.689 second. So if you want to do 0.68 meter, right, you can do the proportion 0.66 minus 0.6 over 0.7 minus 0.6 times what? 1.689 minus 1.565. So basically it's just doing the proportion. Okay, so you get about somewhere in between these two values, which is about 1.6642 second. So total time, so don't forget this is the period. Okay, time taken for one oscillation. So if you have 20 oscillation, you just multiply by 20, you get 33.3 second. Okay, so answer will be D. Okay, next question 3. Which of the following statement concerning the mass and weight are true? Okay, so make sure you know it's true. So first, mass is constant everywhere. Yes, this is true. Okay, so it will not change depending on your location. It will always be the same. Weight is a force that pulls towards the center of the earth. Okay, this is true as well. Okay, the gravitational pull by earth, okay, on a mass of object. Okay, weight changes from place to place depending on the acceleration due to gravity. Basically means your gravitational pull. Okay, so this is true as well, because W equal mg. If your g change, your W will change accordingly. Okay, so it's true. So answer is D. Okay, question 4. Okay, so this one most likely is a mass weight density question. The mass of a paperclip is 0.50 gram. Okay, one paperclip. Density 8 gram per cm cube. Total volume of all your paper clips is 20 cm cube. So how many paper clips are there? So obviously you're going to do your famous formula, density equals to mass over volume. Okay, so you can sub it in. Your density is 8.0, and then your mass 0.50. Okay, and then you find the volume. This volume is the volume for one paper clip. So if you rearrange, you should get 0.0625 cm cube. So this is the volume for one paper clip, but total is 20 paper clips. 20 cm cube, I mean. So you just divide. Number of paper clips will be 20 divided by 0.0625. So you should get about 320 paper clips. A ball is thrown across the flat ground. Okay. So which statement describes the motion of the ball, assuming air resistance is negligible? So let's look at the first statement. The ball lands with the same speed at which it is thrown. Okay, so this one is true, because when the ball, when it's thrown, let's say speed is 5 meter per second. Okay, when it reaches here, it will be 5 meter per second as well. Okay, because here is upwards, it's 5 meter per second. Here, same horizontal level, it will be 5 meter per second, but it's downwards. Okay, so it's true, only the direction is different, but the magnitude is the same. Okay, so it will be same speed. The speed of the ball is 0 at the highest point. Okay, so this one will be wrong. Why? Okay, although at the highest point, right, the vertical speed will be 0, but it's still moving to the right. Okay, so it won't be totally 0. There will be some speed pointing to the right. Okay, so be careful, this is very tricky. The acceleration of the ball is 0 at the highest point of the motion. This is definitely wrong. Why? Because as long as it's in free fall, right, okay, the acceleration is what? 10 meter per second square in any point, at any point during the free fall. So meaning, what is the acceleration once it leaves the hand? Okay, when it's here, is 10 meter per second square. What's the acceleration here? Still 10 meter per second square. Even at the highest point, it will still be 10 meter per second square. Even here or here. The reason is because as long as you are in free fall, the only force acting on the object is gravity. Okay, so the acceleration definitely will be 10 meter per second square. Okay, so this one is a very important concept, so don't get tricked. Let's look at D. The acceleration of the ball is largest at the start and decrease slowly to 0. So C and D are very similar, so definitely will be wrong as well, because it's always 10 meter per second square. So answer will be A. Okay. Question 6. A crate of mass 7 kg rests on a rough horizontal surface. A light string attached to the crate passes over a smooth pulley downwards, okay, by a load of about 2.5 kg. So now when the crate is released, a frictional force 5 Newton acts on it. Means on this rough surface there's a 5 Newton acting on it. So gravity is 10. So what's the acceleration? So first thing first, we need to convert this crate of mass, right, into force, meaning the weight. So your famous formula, W equal mg. Okay, mass is 2.5, gravity is 10, you get 25 Newton. Okay, so the force here is 25 Newton. So because it's connected along the same string, so the force here, right, the pulling force on the crate is also 25 Newton. And then of course they mentioned friction is 5 Newton. Friction is opposite to the motion, so it's pointing to the left. 5 Newton. Then you can do your another famous formula, F total or F net equal MA. Okay, so what are the force here? The pushing force and the frictional force. So it's big F minus small f equal MA. This is the pushing force. Small f denotes the frictional force. Okay, so you can sub in your numbers. This is 25, this is 5, mass is 7. Okay, 7 kg. Then you find A, acceleration. So you just rearrange, you should get about 2.86 meter per second square. Okay, so answer will be A. Okay. Question 7. Two blocks, okay, X and Y, hang on a spring balance at the same location. So which one is true? So make sure you highlight, okay, don't choose the false one. So first thing first, they have the same mass but different weight. Okay, so from the diagram you know it's false. Why? Because both are what? 3 Newton, 3 Newton, but it says different weight, so definitely it's wrong. Okay, so coming back, same location means what? Same gravitational pull. And then from the diagram you can tell both are 3 Newton. And since we know that W equal mg, your weight is the same, your g is the same as well. So it means the mass must be the same. Okay, then you can use your density formula again. Density equals mass over volume. Mass is the same. So from here we can tell the volume, obviously they are different. So different volume means your density will be different as well. Okay, so with all this information, you can read one by one, see which one is correct. Okay, they have the same mass but different weight is wrong. Okay, answer should be B, same weight but different density. Okay, same weight but different density. Okay, the rest are all wrong. Different volume is true, different weight is false. Okay, because both are 3 Newton. There's a different density is correct, but different mass is wrong also. They should have the same mass. Okay, so answer for question 7 is B. Question 8, this one is your moment question. Which forces A, B, C, or D would be the largest force to push the ball up the stairs? Okay, so first thing first, you have to recognize that you are looking for the largest force. Okay, don't forget. And then moment equals to what? Force times perpendicular distance. Okay, since now you're looking for the largest force, okay, and the the moment will be the same because when you try to push it up the stairs, right, the moment you require will be the same. So moment is constant. So if F is the largest, means your D should be the smallest. Okay, and then take note, when you are trying to push the ball up, you can visualize it. Okay, here at the edge of these stairs, right, okay, is the pivot. Okay, so now objective is what? Is to figure out which force will give you the smallest perpendicular distance. Okay, so let's say for A, we can extend it and then perpendicular distance to the pivot. Okay, so it's 90 degrees perpendicular, so it's dA. Okay, so it's quite short here. What about force B to the pivot? The perpendicular distance, if you extend it, line of action of the force, and then your perpendicular distance to the pivot will be dB. Okay, it's quite long here. What about C? Same thing. Okay, perpendicular distance, make sure it's perpendicular. Okay, it's DC. And then what about force D? It will be this length, perpendicular distance. So from inspection, you can tell you're looking for the smallest perpendicular distance. So answer will be A. Okay, so because the perpendicular distance is very short, so that's why your force applied, right, will have to be the largest in order to produce a moment that will rotate the ball upwards on the stairs. Question 9. A child jumps on a trampoline and bounds upwards. On the second jump, he bounds higher. Which one is most likely to remain constant? Okay, so this one is very similar to your free fall. Okay, you want it to stay constant. So we know that A equals to what? 10 meters per second square in free fall at any point. So answer straight away will be A, his acceleration in the air. As long as he's in the air, okay, the only force acting on it will just be the weight, which means the gravity is only 10 meters per second square. Okay, the rest will change because GPE, gravitational potential energy, the higher he is, the higher the GPE, and then KE, maximum KE will be increased as well, and then the speed on contact will be different as well. It won't stay constant. So answer for question 9 is A. Question 10, this one is a density question. So which of the following is true? Okay, so you can use your formula, density equals to mass over volume. Okay, so first thing first, let's look at option A. A gram of iron has a smaller volume than 1 gram of copper. So statement A is false. Why? Because with a constant mass, because both are 1 gram, 1 gram, constant mass. If your density decrease, your volume should increase. Okay, if your density decrease, volume should increase. So means iron, if you see from the table, it's 7.9. Okay, but what about copper? It's 8.9. Okay, so it's not correct. Okay, iron should have a larger volume. Okay, the volume should increase much higher than the volume of copper. Okay, so A is false. What about B? 1 gram of mercury has a greater volume than 1 gram of water. Okay, same mass again. Okay, constant mass. So now, if you see carefully, mercury is here, 13.6. Okay, water is about 1 gram per cm cube. Okay, so density of mercury is higher, so means what? The volume of mercury should be lower. Okay, but they say mercury volume right is greater, so which is false. Okay, what about statement C? The mass of 1 cm cube of mercury is greater than 1 cm cube of any other substance, meaning assuming same volume, comparing all the liquid, all the substance, different same volume, I mean, excuse me, the density increases because can you see mercury density is the highest. Okay, this is the highest, and this one stay the same. So means what? The mass of mercury should be the highest as well. Okay, the mass of mercury should be the highest as well. So it's true. Okay, so statement C is true. What about D? Just for completion's sake. Okay, the mass of 1 cm cube of water is smaller than 1 cm cube of any other substance. So assuming same volume, okay, same volume. So they say the mass is lowest. Okay, so let's look at so density should be the lowest. But if you see carefully, density of water is not the lowest. In fact, kerosene density is even lower. Okay, so it's not true. Okay, the mass of 1 cm cube of kerosene then is the smallest among all other substance. So that's why statement D is false as well. So answer for question 10 is C. Okay, so that's all for this challenge. So don't forget to like, share, and subscribe. Okay, bye.